Good morning, class, and welcome to this lesson on Magnetism 7, the right-hand rule number 2. Today, we will be able to identify the direction of forces or magnetic fields of multiple wires carrying a current. So, there's going to be nothing new here. If you understand right-hand rule number 2, then there's nothing new. What I'm going to do is I'm going to try to give you some tips for multiple wires, and just tell you how to solve these problems because they do become very difficult, especially when dealing with a 2D piece of paper. And like I said before, this is going to be a very difficult video to explain, so just try and go with it. And if you don't get it, then we'll talk about it more in class, okay? We definitely will talk about it more in class. So, when we have multiple wires, when we have multiple wires, we know these wires are carrying a current. They both have a current. Both these have a current, and we want to know how these are going to affect each other. This is a very common question. Okay, so I want you to look at wire number 1 right here, and all these problems we're going to do right-hand rule number 2, right-hand rule number 2 first, and then we're going to do right-hand rule number 1, which seems kind of backwards because it's just 2 first and 1 next, but whatever. Okay, so I want to know what the force is on wire 2 based off wire 1. So to do that, I'm going to do right-hand rule number 2. So what I'm going to do is I'm going to take my thumb, I'm going to put it in the direction of this wire. You should do this too. And then I'm going to curl my fingers around. I'm going to curl my fingers around it like this. Okay? My fingers would come into contact with this plane right here, this plane, and they would be facing upward. So my fingers would curl around this, and when they come into contact with this wire or this plane, they would be facing up. So that means the magnetic field here, as you can see, is pointing up. So I did right-hand rule number 2 first. I'm going to do right-hand rule number 1 next. So using this wire now, I'm going to take my thumb, point it down this way. So my thumb is pointing down. My fingers are going to point straight up in the air. So my thumb is pointing down, my fingers are pointing straight up in the air, my palm is facing outward, or it's facing this way. So if the currents are opposite, the force will be outward. The force will be outward. Okay, so the current is opposite, the force will be outward. So you can see here, if these two wires had these currents, these wires would actually bend away from each other because the force is pushing them out. And likewise, if I go to this one over here, just to be thorough, if I did right-hand rule number 2 on this wire number 2, my thumb would be pointing down, and I would curl my fingers under like this. My thumb is going down, I curl my hand around, my fingers would come into contact with this thing and they'd be pointing upward. So B is pointing upward. Okay? So if I do right-hand rule number 1 now, my fingers are pointing up, my fingers are pointing up, my thumb is pointing down this direction, my palm is facing outward, the force is outward. On the flip side, let's say they both have the same current. So I'm going to do the same thing, okay? Right-hand rule number 2 first. I'm going to take my thumb, point it down this wire, curl my fingers around this way. My fingers are pointing up. So the magnetic field is pointing up. Let's do right-hand rule number 1 now. I'm going to take my thumb, point it along this wire right here. My fingers are pointing straight in the air. My palm is facing inward. So if the current was in the same direction, these two wires would be facing, or they would be facing, they would be bending towards each other. Okay? So this is a very common question. And so if the currents are in the same direction, then the wires will be attracted. The wires will be attracted, as we can see by the force here, okay? So that's just one example, okay? Let's look at this example. The question here states, will this wire and this loop be attracted or repulsed from each other? Okay, so if I do right hand rule number 2, my thumb is going down and I curl my fingers around. That means the magnetic field is going to be pointing into the board here, into the board. And it's going to be pointing into the board on both segments, okay? It's going to be pointing into the board on both segments. So if I did right hand rule number 1, my fingers will be pointing into the board for this segment right here. My fingers will be pointing into the board. My thumb will be facing in this direction right here because that's the direction of current, and my palm will be facing up. So the force would be up. If I did the same thing for this segment down here, my fingers would be pointing into the board, my thumb would be facing to the left, current facing to the left, and my palm be facing down. So the force would be facing down. So the question is, will this be attracted or repulsed? And the answer is it would be attracted. The question, because of our equation, B equals the permittivity of free space over I over 2 pi r. R is a smaller number at this point right here than this point right here. So the magnetic field will be greater up here than down here. So the magnetic force will be greater up here than down here. Very difficult question. I'm going to give you a couple other minor examples. You might get a question like this where you have 2 wires and they want to know what is the magnetic field here at point P? Why not? Okay, and this wire has a current going this direction. This wire has a current going this direction. And then you know this distance R1 and you know this distance R2 and you know the 2 different currents I1 and I2. What is going to be the direction of the magnetic field at point P? Well, if I do right hand rule number 2, my fingers curl around. My fingers curl around this wire and they would be facing out of the board here at point P. And if I do it for I2, they would be facing out of the board at point P. This would be B1, this would be B2. So my B's would be equal to epsilon naught times I over 2 pi r plus epsilon naught I over 2 pi r. And I would just plug in my r values and my I values. So they would add on there. On the flip side, if I had 2 different wires, so let's do a wire like this. I'll do a similar problem. Currents going this way in one, currents going this way in another. We have point W, why not? And we have R1 and R2. Okay, this current's going up. So from I1, if I curl my fingers around, in the plane of the board, the magnetic field would be coming out of the board. And in this one right here, the magnetic field will be going into the board. Because if I have, in this one right here, if I have my thumb pointing up and my fingers curl down, my fingers would come into the plane of the board going in. And so if I want to know the magnetic field at letter W, I would just do B equals, mess that up. B equals this times I1 over 2 pi r1 minus I2 over 2 pi r2 because one magnetic field is going into the board, one magnetic field is coming out, one magnetic field is coming out of the board, one's going into the board, and therefore they're going to cancel out with each other, okay? Or they're going to partially cancel out, either way. Once again, I understand if you did not understand this lesson completely, we will go over it in class and we'll have props and all kinds of stuff. But the reality is if you have multiple wires, you need to do both right-hand rule number 2 and right-hand rule number 1, and you need to figure out the direction of magnetic fields and forces. And if you understand that, then you have 95% of the questions that I probably will ask you.